Okay, so the last speaker for today, Emanuele Rampichini, will show us how to build a desktop streaming console with Electron and ReactJS. Enjoy.
Hi everyone, the title is actually quite wrong. I start with something wrong, so it gets better. How we build a desktop streaming console with Electron and ReactJS. I'm not going to explain how to build it, but how we did it. And I will start with who am I? Simple things. I'm a software engineer at Spreaker. We are a podcast company. I am a JavaScript enthusiast. I love JavaScript. I've been working in JavaScript for my last 4 years. And I like to push random code on GitHub. You can find my GitHub account there. I'm not so active on Twitter, but you can follow me. I'm always happy having follower. And I'm a mountain bike lover. I don't know why I had it, but I wanted to give some background on me. And who are you? I suppose you are a software engineer somewhere. Otherwise, you wouldn't be there. And I suppose that you're a JavaScript enthusiast because you are listening to this talk. And you have your GitHub account, you have your Twitter account, and you have other passions. And the most important thing is, why are you listening to me now? Why it's the last talk? And maybe you don't want to listen to me, you just want to go home, you just want to take a nap in the last 45 minutes. Or you may be interested in how to build a cross-platform desktop application using JavaScript and web technology and ReactJS. How much your word? Yesterday at the speaker dinner, when speaking with the other guys, they all were thinking about, it looks like a toy project what you're talking about, and actually it's not like that. We're talking of something like Visual Studio Code. It's released by Microsoft. We're talking of something like Mapbox Studio. It's a desktop app for editing maps. Something like Slack client. I don't know how many of you use Slack, but it's built on web technology. And we're talking specifically about Spreaker Studio for Desktop. That is the application I'm going to talk about. What we wanted to do. We wanted to use HTML, CSS, and JavaScript with Chromium and Node.js to build a podcast streaming application for content producers. Why we wanted to do that? Because at our core, we are a web developer. We are not native desktop developer, and we love the web, and we love the technology and what's on the web. And the first problem we encountered was a decision. Like at every start of the project, there's a big decision to make. And in this case, we had two technologies, main technologies, not WebKit.js and Electron. They are quite similar. They have small differences, but they both do the same. They offer you a web shell, and they expose you the native operating system with the Node.js integration. We had a prototype built on Node WebKit from 1 year ago. It was in advanced state. It was working, but we decided to throw it off to choose Electron. Our winner was GitHub Electron. It's the spin-off project born from Atom Editor. I don't know how many of you know that. And why we choose Electron? Because it was faster, and by faster I'm not saying it was faster for the performance, but the release cycle. They have a 1 week release cycle. They are following Node.js and Chromium versions 1-to-1. So where there's a new version, Electron has a new version. It's stronger. It has a huge community. A lot of big companies are investing on it, and you can see that on GitHub activity. And I'm not talking about star or forks. I'm talking about contribution from people working at Slack, from people working at Microsoft, contributing back to the source code of the project. And it's simply better. And you're going to understand why. How many of you know how Electron or Node WebKit works? Okay, that's not a lot. Okay. Actually, it's super simple. The basic architecture of an Electron app is like that. You have a manifest, package.json, classic application manifest, where you describe the entry point of your application. It's a plain Node JavaScript file, and in that main process, you can spawn browser windows. You can control the life cycle of the application, so you can attach to events on the various window you're handling, and you can spawn application with the load URL function. Once you load this application, you have a web page. Basically, you have a web page, an HTML, but it's much more than a web page, because in a script tag on this web page, you can require native modules, Node modules, and you can go out of the sandbox. You can access file system, you can access socket, you can do whatever you want. Whatever, if there's an NPM module for that, you can use it, and that's it. That looks very interesting, not only on the native integration side, but on the front-end side. Being the front-end engineer, we are here, and we're talking about something cool about front-end engineering that is happening now. It's moving fast, and it's challenging and changing all we knew about front-end development. And that's happening on the browser now. Classic toolkits are behind. They are 2 steps behind. If you want to work with Cocoa or Windows Presentation Foundation for Windows, you don't have the new instruments that you have on the web. The front end is moving on the web. And basically, you are writing a client app, a single page application or multi-page application. You can decide that. It's up to you what you want to do. For our product, we decided to build our application on a technology stack, and I'm going to explain why and what made us choose these tools. We use ReactJS for the view part. We use System.js for the bundling of the application and dependencies management inside the application. We use JSPM as a package manager to build our app with external vendor dependencies. We use Babel with ES6 to be future ready. We started that 5 months ago, and we didn't want to start something with old ECMAScript 5, because it was in that period they accepted the final standard, so we decided let's go with it. And we used a ton of other libs, the one you always love. Why ReactJS? It was an easy choice. Not so easy for me, because I came from 2 years of AngularJS development. And I love Angular. I spend a lot of time with developing Angular application, but when I started working at that kind of application, I knew that it wasn't a good fit. We chose React.js because it was unopinionated. It's a view framework, as everyone said here. It does its job, does it well, and it sticks to that. It doesn't want to do more. It's up to you how you want to use it. And an application like that is borderline. It's not the classic web form-based application. It's an interactive mixer. And we wanted to have freedom to change our internal architecture. And React was an opt-in solution. We can just decide to use that. It can be fast enough, In this application, we're dealing with timers, real-time timers. We update sliders, things that run a lot, and we have to do that to let it feel smooth. We have to do it every 60 milliseconds, so you get the 60 frame per second target. And it was quite good handling that. Try to do that with Angular bidirectional binding and tell me what happened. You're going to see your PC something like that. And it was battle tested by Facebook. If it works for the largest code base in the world, for the bigger company, it's going to work for us. We're going to find a way to make it work for us. How ReactJS? We didn't push too much on the architecture, given the kind of application. We had to think a lot about the native part and the mixing, and we didn't want to experiment too much on the front-end side architecture. So we went with a simple architecture. We use the classical multiple store single dispatcher Flux architecture for something in our application that is user interaction, web API, so web API and callbacks from the server, and push notification. We have a push notification that is that events that are put into the dispatcher. And we rolled out our solution for specific problems. For example, we used a lot of event emitters for some dedicated task I'm going to explain. We use some abstraction with the finite states machine to handle, for example, connection or reconnection of the streaming socket. So we decided to take each single problem and find the most appropriate solution to the single project. We didn't want one size fits all solution. We didn't want that, and we used quite a lot of stateful components because we all know that functional purity is something wonderful. It gives you a lot of wonderful side effects, like Massimiliano, like you saw in Massimiliano talk. You can time travel, you can debug. It makes everything easier, but sometimes you have to deal with performance. And when you do fast updates at 60 milliseconds, every function call counts. And what we did in that case was using stateful components for high-frequency updating components. So our stores model is not pure. In some store, we send back to our components event emitters. And doing that and pushing down the component tree, the high frequency models, event emitter, you know that your view will render only that subtree. That is the minimum possible. You don't want to render your application every 60 milliseconds. You're gonna see your computer explode. It's always the same thing, the same problem. And so it's a trade-off. We did a trade-off between purity and performance, and for an application like that, performance win. We used. I want to talk about the higher, not the software architecture, but the building application we used, the building architecture, and I'm going to talk about System.js and JSPM. I'm going to talk about that because nobody is talking about that. Everyone is talking about, someone is talking about Browserify, and they say, oh, it's quite cool, but it's old. It has 2 weeks in the JavaScript world, so it's super old. And that's Webpack, it's super. And that's JSPM that no one is looking at, but it's very good. It's a universal dynamic module loader, and it's based on the new ES6 module specification. It's built upon ES6 module loader.